All right, let's look at another example for a 1-mean-Z test. Sulfur compounds cause off odors in wine, so winemakers want to know the odor threshold, the lowest concentration of a compound that the human nose can detect. The odor threshold for dimethyl sulfide in trained wine testers is about 25 micrograms per liter of wine. The untrained noses of consumers may be less sensitive, however. The DMS odor thresholds for 10 untrained students are on the spreadsheet tab labeled wine. Assume that the odor threshold for untrained noses is normally distributed with sigma equal to 7. Is there evidence that the mean threshold for untrained tasters is greater than 25? All right, I would like you to pause the video and give this one a try. All right, so let's go ahead and see if we got similar results here. So the P for phantoms, what are they asking us to do? We're looking at testing the claim that the mean threshold for untrained tasters is greater than 25. Okay. Two hypotheses. We have a null and an alternative. And again, we're testing the population mean, so we're going to use that symbol mu. We have an equal sign for the null hypothesis. And we're looking at, is it greater than 25? So we'll use 25 for both of these, the null and the alternative. And we're looking at greater than. So we have that symbol there. And that's going to give us a right tail test. And then we have A for our assumptions. I'm going to go ahead and put the rest of the letters down the side here. Okay, so we have simple random sample, normal large, and sigma. Okay, so I did not see anywhere in here where it said that we had a random sample. So I'm going to put a star here and put not stated. Okay, we're going to go ahead and go through the rest of this test because that is good practice. But in your conclusion, if you were doing a write-up for this in terms of like research, in case you're doing some sort of paper, you would really need to address this issue, that you didn't have a random sample here. So for right now, we'll just put a star there. We'll put not stated. Our sample size is 10, which is too small, but it does state in the problem that we can assume that it's normally distributed. Okay, so I'm going to circle the word normal, and I'm going to put a star and put stated in problem. Okay, your other option would be to look at the normal probability plot. And so if the normal probability plot was acceptable, then you'd put a little star and put MPP looks straight enough. Okay, so something to that effect. And then sigma is 7. So since we have our population standard deviation, that tells us that we have a Z as in zebra distribution. So we have a 1-mean-Z test. And then it's time to look at my test statistics. So Z is X bar minus mu, sigma over root n. So I know that my mu is 25, my sigma is 7, and my n is 10. But I don't have an X bar. So I need to go to this spreadsheet that says wine, and I need to go get X bar from that. So if you've downloaded that and did that, I came up with 29.4 for that mean. And then we're going to go to the spreadsheet that has our calculators for the hypothesis testing, and we will get our test statistic and p-value from that. All right, so let's put in our information. My X-bar was 29.4. Mu, which came from my null hypothesis, is 25. Sigma was 7, and n was 10. It gives me a test statistic of about 1.98. Just remember you want to do about at least 2 decimal places when you write that down. And then our p-value, let's write that down while we're here. We had a right tail test, so our p-value is 0.023. It's a good idea to write down 3 to 4 decimal places for the p-value. And that's all we need off the spreadsheet. So we'll pop back over to our classwork. All right, so here I've written down those numbers from our spreadsheet. And then we need to compare P to our alpha. You'll notice that they didn't give us an alpha anywhere in this problem. So if they don't give us an alpha, then we're going to use 5% or 0.05. So if there's not one stated, then it's just fair to assume that it's a 5% alpha. Yeah, it's kind of in the middle between the 1 and 10%, so it's kind of a good go-to if it's not given. All right, so this is 0.02, this is 0.05, so P is smaller than alpha. So that means we do reject the null. So remember, whenever P is smaller, that means we're further out in the tail, so we are going to reject. Okay? If P is bigger than alpha, then we do not reject. Okay? And then all that's left is to write our conclusion. So we'll use P, O, and M in writing our conclusion. So with a p-value of 0.023 at the 5% significance level, we do have sufficient evidence that the mean threshold for untrained tasters is greater than 25, it's going to be micrograms per liter. Looks like that. All right, so there is our conclusion, and that kind of wraps up our one mean Z test. I hope that you are getting the hang of this, but if you have questions, feel free to send me an email or visit me on Zoom office hours. I'm happy to give you a hand with that.